Stay tuned because later in this video, I'm going to show you how to take this starter input prompt that's simply just a couple of sentences and get today's framework to optimize it into something that does full chain of thought reasoning traces just like these to improve your prompts massively. Okay, so one of the things that I've mentioned on the channel time and time again is that the quality of the outputs you get from an LLM are totally conditional of the context and the inputs that you put into this. Now, this sounds really obvious, yet time and time again, I see people making this mistake of not optimizing their prompts, of not thinking about what kind of context should be going in with the prompt, of thinking about things like in-context learning, etc. And that brings me to today's tool that I want to talk about, which is a new framework from Microsoft called PromptWizard. And the idea here with this framework is that it's trying to help you optimize the prompt that you use for the instructions, what in-context learning examples, how many, etc., and overall just what you put into the model for a specific task. So you can imagine this is a really important thing for big companies like Microsoft, like Google, is that as they train up new models, in fact, as they even fine-tune new models, often the prompts needed to get the best result out of that model will change. Now, this is something that many labs have worked on trying to standardize so that just one simple prompt for a task would be able to get the best results out. Yet so far, no one's really conquered this. And this leads to prompt engineering still being a thing multiple years after it first came on the scene. Now, the models in general have gotten a lot better, so therefore it's perhaps not as magical as it was before. And I think the education around prompt engineering has gotten a lot better. So people are sort of learning how to set the context, how to give it some kind of identity, etc. But PromptWizard approaches this whole thing as an optimization problem. And not only are they looking at getting the best prompting to create a correct answer out, they're also interested in getting the models to be able to generate better chains of thought out and synthetically generate chains of thought, which is exactly what you could imagine people wanting to do if they want to train up reasoning models where they've got both correct chains of thought and incorrect chains of thought that they can train on to get models better at generating out reasoning via chain of thought patterns. So let's jump in and have a look at this. So Microsoft clearly knows that this is a big problem at the moment with what they're working on. They really want to have an optimized way of doing this that's not just human trial and error, etc. And this is where they're introducing PromptWizard. So this framework is designed to automate and simplify prompt optimization. The idea here is that it can use a model to get feedback from LLMs. It can use a LLM as a judge to critique the outputs and then update the inputs going in for producing those outputs. And then over time, it's able to both evolve those instructions and also the in-context learning examples that are going in there. So they talk about three key insights in here. The first being feedback-driven refinement. So PromptWizard leverages an iterative feedback loop where the LLM generates critiques and refines its own prompts and examples. This is at the simplest level. The next level is basically where it's doing joint optimization and starting to create synthetic examples that are diverse, but still in line with the tasks that you're trying to do. And then thirdly, and perhaps most interestingly, is the whole idea of this self-generated chain of thought steps. So this is incorporating chain of thought reasoning to improve the problem-solving capabilities of the model. So if we have a look at this sort of diagram, we can see that you're going to input a problem description. You're going to input some kind of prompt instruction for that. So this is the question that you want to answer. Then you're going to have some kind of instruction for this. So you could think of this as being like a system prompt, a developer prompt, etc., that's giving clear instructions of how to handle the question above. And then you're going to have some in-context learning training examples in there. Now you can see that what this will do is basically refine those prompt instructions so that they get passed along and we can test out different modified prompt instructions. It will select diverse examples from your training examples for the in-context learning, and then be able to generate synthetic examples out. And then finally, it can generate out these sort of self-generated reasoning and validation. This is going to be through the chain of thought, etc., until finally we get a clear, optimized prompt, some optimized few shot examples with the reasoning chain of thought, etc., and the sort of task intent and expert persona that we can use coming out of this. Okay, so if we look at this in a little bit more detail, we can see that stage one of this is the refinement of the prompt instruction. So this prompt instruction that goes in, obviously you're going to pass that in with the problem. In this case, PromptWizard also passes in some sort of thinking styles. So this is a little bit similar to the DeepMind prompt breeder idea of where you sort of mutate prompts. And you can see we get a set of mutated instructions and stuff like that. These can then be scored to see, okay, what went well. And we can take each of these mutations and see that, okay, this one came back out. So we can now critique and synthesize that to improve the prompt instruction. And then you can go through it again in a loop as you're going through this, because each time you're passing in a separate sort of pass, you don't have to worry too much about passing in the same problem descriptions, etc., going through this. So this point is doing the sort of mutation stuff based on these thinking styles. And then here we're doing all the sort of scoring and evaluation and getting, feedback from the LLM for this. Then once we've got those scores, we can then basically critique it. Why was this better, etc., and synthesize a new prompt that comes out even better. And the idea is this is a loop that goes through, and you can choose how many times you want to go through the loop to improve the prompt instruction. The second stage is where you're now combining this with the in-context learning examples, etc. And so you're passing in these examples, you're critiquing and synthesizing, and you're critiquing those examples and then synthesizing new ones, combining it with any sort of modified instruction, again, critiquing and synthesize going through. So this strengthens it even more and allows us to basically get these better chain of thoughts for doing reasoning, etc. at the end on this. All right, so I don't want to go too much over their benchmarking, etc., but they show that this is doing better than things like Prompt Breeder. Prompt Breeder is the one I was talking about before from DeepMind. Evo Prompt, I've talked about Evo Instruct, and it had some really interesting ideas of generating synthetic data and examples for training, etc. And I think the Evo team is actually working at Microsoft now. All right, let's jump into the code and have a look at how this actually all works and comes together. Okay, so we can see that Microsoft has released the framework. It's got a nice MIT license. We've got a little bit more stuff here around explaining it. There is a paper, if you're interested to go through the paper, that explains it a little bit more in detail and stuff like that. But we can see in here that it's going through the bits that I talked about from the blog post. And then in here, they've got some different sort of scenarios for how you would want to use this. Now, by default, it is set up for OpenAI and for Azure. Not a big surprise coming from Microsoft. My guess is that you probably can rewire the OpenAI endpoint to go to another model. And they do have a class in here for custom models as well. So the one that I'm going to walk through setting up is the GSM 8K datasets. So the way that this works is it starts off with something like a description where you can see the assistant prompt, etc. You are a mathematics expert. You'll be given a mathematics problem, which you need to solve. Then it would be the question, and then let's think step by step. So that's just the base instruction in here. Now, at the end of this, they also have it so that you have, at the end, wrap only your final option between answer start and answer end. So that's for checking to see if it got the right answer, etc., going through this. Okay, so let's jump in here. I've put together a Colab notebook where you can just basically try it out and run it yourself. So we're just importing the Microsoft Prompt Wizard and setting it up. One of the things that you want to do is you want to set up some of the environment variables in here. So apart from just using things like the OpenAI key, you also want the Hugging Face key in this case because we're downloading GSM-8K for data sets. And this is a good one to look at because if you look at that data set, you could remake your own custom one for your particular use case and stick it up on there and stick it up on Hugging Face to use later on going through there. All right, once we've got the environment variables set up, we're just doing the imports. We're not going to use their environment thing because we've got no .env file in here. I've just put those in here for what it is that you want. This is for setting up for GPT-4o. If you wanted to, you can do 4 mini, etc. I'm not sure how well it will work with O1, especially considering you're telling it to produce different kinds of chains of thought. OpenAI doesn't like it when you do that on the O1 models. All right, so next up, we've got basically just some code for dealing with the GSM-8K dataset and processing that. And this is just loading this up, bringing it in so that you can actually go through and use this, etc. And then you want to set up your configs. So if we look in here, you'll see that there are a number of demos in here. And under the demos, you've got the various demos and you've got a configs folder and they've set up the basic YAML setups, etc. in there. So coming over here, you can basically just define where all of that is. And then I'm just looking at the actual things out. Now, using a different model than GPT-4o, you will need to come in and change that in the YAML for this if you want to use something different than that. All right, next up, we basically just set this prompt optimizer up where we're passing in the configs for the different things. We're passing in the training file name and in this case, the dataset processor, the GSM-8K. And here we're basically just kicking it off. You've got different settings for the prompt optimizer in here. You've got use examples. So we can just basically use the examples from the training set in here. And so here it's basically just making a mixture of training samples. So here it's just basically going to use some of the examples and then it's going to synthetically make other ones in there. If we've got no training examples and we just want to generate everything synthetically, we would set this one to be true. And then lastly, this one in here can be used when there are no training samples and you really don't care about ICL in the final prompt, etc. in there. All right, you'll see that this ran for quite a while, probably a good 20, 30 minutes running through this. And what it's doing is actually going through 3 iterations of batching these examples and then running the prompts and then mutating them. And you'll see this. So the base instruction starts out like we looked at before is let's think step by step. And you'll see that up here. And the number of few shot examples that we're passing in is 5. And so this is a pretty simple kind of chain of thought, right? We're not really giving it much in there at all. We're just basically saying, let's think step by step. And the sort of original system prompt in here, or this sort of identity thing is basically you are a mathematics expert. You will be given a mathematics problem, which you need to solve. And then it's got these meta prompts. And these meta prompts are sort of the thinking styles that encourage it to mutate the different things. So you can see this meta prompt here is how could I devise an experiment to help solve that problem? And then it starts to mutate and we start to see some of these mutated prompts coming out. Okay, so you can see from that meta prompt, it basically generate out, make a list of ideas for solving this problem, apply them one by one to the problem to see if any progress can be made. And it's sort of gone through those. And then gradually it's starting to mutate these. So rather than just let's think step by step, we've got let's break down the problem into smaller parts and tackle each one systematically. How can we simplify the problem to make it more manageable? What steps do we need to solve it? What are the key assumptions in here? And it will just go through around this. Now, each time it's doing this, it's going to mutate these, looking for better examples as it's going through this. And we can see then it starts to test these on different GSM-8K questions going through here, test them on quite a number of them. It gets a score back, and then it starts to critique these going through. So prompt to critique in here. I'm trying to write a prompt for a zero-shot instruction task that will help the most capable and suitable agent to solve the task. my current prompt is, you are a mathematics expert. You will be given, things, let's think step by step, what we had before. And then now it shows some examples of what it got correct. It basically asks this to critique this. Since you can't use these examples, analyze and understand characteristics, complexity, diversity of these examples and their reasoning chain. This is where we're starting to get to the chain of thought coming out, and accordingly provide suggestions to further improve the prompt and make it better as a zero-shot instruction. All right, so now the critique back from the LLM says that, okay, clarify the role and approach, encourage detailed explanation, highlight the goal. Now, if you think about these sort of things, these are chain of thought things, and they're actually the kind of thing that you see in the summaries coming out of O1, or certainly in the original O1 preview and the O1 mini models that you get here. So finally, it's going through that, and then it starts to give it a revised prompt. So the revised prompt now is, you're a mathematics expert solving complex instructions. For each problem you encounter, follow the steps. And now we've got a set of steps, not just a one-line kind of thing saying, hey, let's think step by step, etc. All right. As it goes through this, it does this over and over again. And it's then also going to, here you can see we've gone through one of the iterations. It keeps going, through this, getting better and better. And then gradually, as it goes through this, it can also work out what are the best examples for this. So let's look at the output for the best thing that came out. So remember, we started with, let's think step by step, and a little bit about, you're a mathematics expert. And now we can see the final one that we get out is a massively more enhanced prompt. So we've got, you're a mathematics expert tasked with solving a variety of mathematical problems. Follow this structured approach. Then we've got comprehend the problem, a whole bunch of stuff around that. Extract key information, stuff around that. Plan strategically, execute with precision, handle percentages and proportions. So that's something that's unique to this, as opposed to, say, like a creative writing task or something like that. Verify and cross-check, logical consistency check, present the solution. Now, then we've got the in-context learning examples, where we've got the original question from the GSM-8K data set there. And then we've got the answer with these chains of thought. So you can see, extract key information, total amount spent, cost of each pair of shorts, number of shorts, cost of it. It's sort of rephrasing all of this out of the question. Plan strategically, calculate the total cost of shorts. And then it's got going through each of these, verifying cross-check, logical consistency check, a whole bunch of stuff there, present the solution. And then it gives the answer in this format, which is for checking, etc. And then it's got a guide for each question, present the reasoning followed by the correct answer. And then this part, expert profile, is actually like a system prompt that you could use, that it generated also, where it says, you are a mathematics expert with deep understanding of various mathematical disciplines, including algebra, calculus, geometry, statistics. You have a strong analytical mind and are skilled at breaking down complex problems into manageable steps. And it's going on. I'm not going to read it all out, but you can see that this is a super long sort of system prompt that has been tailored to this GSM-8K dataset. Now, if you made your own dataset for a particular kind of thing, you could have this run through and be able to build the best prompt for you for your particular kind of problem. And this is one of the things that I see people make a lot of mistakes around agents. Often you don't need an agent. And the reason why people end up using agents is that the agent ends up doing the different kinds of prompt writing in there. If you've just got something simple where you can define, okay, at this point, this is the input, this is the output I expect. At this other point, here's the new input plus the output of the previous bit, etc. You can just chain everything together. The whole idea of chaining the prompts together and getting the best outputs is really all that people need for most use cases with LLMs. All right. Finally, it allows you to save it in here, and then it allows you to basically test this. It's still going through the test of this as I'm recording here. So PromptWizard gives you a comprehensive way that you can go from having just a set of evals and tests, and maybe you've got your own basic prompts in there, to having a fully optimized prompt and optimized kind of system instructions, or this intent and expert persona that you get out at the end there. It's definitely worth looking at if you're doing a big project with a team, etc. You've already got some evals, just run it through this and see how different are the prompts that it's generating compared to what you're using for the different models that you're using. So you could come in and customize this to, like I said, you can probably change the endpoints to work with other APIs that support the OpenAI format, etc., quite easily. And then you've got something that can optimize prompts for a whole bunch of different task-specific things that you want to use it for. All right, so hopefully you can see the value in this. I'd love to hear back from people what you would like to use this for. And of course, if you've got any questions, etc., please put them in the comments below. I'm certainly going to be playing with this for some of the projects that I'm working on to work out the best prompts. And I really like how this builds on some of the things that I've talked about before, like eval, instruct, and prompt reader, etc. As always, if you like the video, please click like and subscribe, and I will talk to you in the next video. Bye for now.